Welcome learners. My name is Mr. Pochilola once again, representing BLACKSLIDES Online Secondary School. We meet now to continue looking at measurements 2. We are going to dwell on a subtopic, measuring lengths, with focus on instruments for measuring length. So welcome to the lesson. If you are watching our video lessons on YouTube and you have not subscribed to the channel, consider subscribing to the channel so that every time we upload new material there, you are notified on time. So welcome learners. We are going to look at how you can measure very small lengths using the Vernier Caliper, a pair of Vernier Calipers, the Micrometer Screw Gauge. We shall also, in passing, talk about the limitations of a rule or a ruler as a measuring instrument. If you are considering to join us on our main classroom, don't hesitate to send us a text message to the numbers shared here, or better still, just call us on the numbers, the same numbers. If you have the capability to email us, simply send us an email address, an email message giving details of your question or inquiry to the email given here. We should be able to come back to you with feedback. Welcome learners. So invite your friends to join our ever-growing learning platform, which is called BLACKSLIDES Online Secondary School. Take note that we don't teach on WhatsApp. We have an online platform where all lessons are delivered. So in order to join the classroom, simply send us a text message expressing your interest to join us there. Welcome learners. But if you are watching our video lessons on YouTube, where the content delivered there is not as detailed as it is in the main classroom, consider subscribing to the channel so that you are able to learn from the little that we share there. Welcome learners. So our holiday lessons have started on the 1st July and they are way in progress. In case you are considering to join us, don't hesitate. Simply send us a text message. We should be able to have you enrolled. Welcome learners. So in this lesson, we are going to look at the use of the Vernier Calipers, Micrometer Screw Gauge as instruments used to measure very small lengths. We shall also talk about the limitation of a ruler as a measuring instrument. So in this lesson, we are looking at measuring length. We shall briefly talk about the limitations of a ruler as a measuring instrument, and then progress to the use of a pair of Vernier calipers to measure very small distances or lengths. And later on, we'll talk about how you can use a micrometer screw gauge to measure very small lengths. I feel it is important that you understand something about length. We shall use the term length in this lesson to mean the distance between 2 points on an object. So you talk of length of a piece of wire, you can talk of length of a table, you can talk of diameter of a ball bearing, you can talk of radius of a circular object, and talk of different other lengths. So length is just distance. Just a reminder, length is measured in units called the meter, although there are other units such as the centimeters, the millimeters, the micrometers, the nanometers, and the like. But in scientific work, length is measured in meters. In Form 1, you learned that length can be measured using a tape measure or a meter rule, also called a meter ruler. There's a difference between a meter rule and a meter ruler. You can explore the differences in your own time. So a meter rule is used to measure the length of distances between 1 millimeter and 1 meter. What this means is that the least distance, the least length that a meter rule can measure is 1 millimeter, and it can measure up to 1 meter. It takes 1000 millimeters to make 1 meter, or it takes 100 centimeters to make 1 meter. So welcome, learners. Alright, so a meter rule is calibrated in centimeters. It can also be calibrated in millimeters. The smallest, the tiniest division on a meter ruler is 1 millimeter. 1 millimeter is just 1/10 of a centimeter, but it has the versatility to measure up to 100 centimeters. Welcome, learners. So a rule or a ruler can only measure large length, as large as 1 meter or as large as 100 centimeters. But very small lengths can be measured using what we call a Vernier Caliper and a Micrometer Screw Gauge. That's the focus of this lesson. We shall look at how you can use a Vernier Caliper or a Micrometer Screw Gauge to measure very small lengths. While a ruler is such a useful tool for measuring length, it has limitations or challenges. The major challenge of using a ruler to measure length is that it fails to measure the second digit of a decimal fraction. In other words, a ruler can only register up to one place of decimal, but it fails to register the second digit of the decimal fraction, as we shall see. For example, 2.2 centimeters can be seen easily on a ruler, but you can't show clearly 2.24 centimeters. This is difficult because it does not show us 0.04. A ruler cannot show a reading of 0.04. is way too small. So that's the limitation a ruler has. It fails to measure the second digit of a decimal fraction. For example, here 2 centimeters will be up to that mark, and therefore 2.2 is going to be up to here. But for us to register 2.4, which is slightly here, the ruler cannot show that division. That's its weakness. It can't show us 3.18. No, it can show us 3.1. 3.1 is here, but 3.18 is not possible. So that's the limitation a ruler has as a measuring instrument. Welcome, learners. So we are going to look at the use of vernier calipers and micrometer screw gauges in measuring very small distances or very small lengths. So a vernier caliper is shown in the diagram here. We use vernier calipers when smaller and accurate measurements are required. So a vernier caliper can be used to measure internal and external diameter of objects, such as test tubes. You can use vernier caliper to measure the internal and external diameter of a pipe or such similar objects. So structurally, a vernier caliper has two main parts. It has what is called the main scale. The main scale is this one, which looks like a ruler, starting from 0, going all the way. So this is called the main scale, which is fixed. Fixed means it's not movable. It's usually numbered in centimeters. So you have 0, then 1 centimeter, 2, 3, 4, 5, 6, and so on. This is called the main scale. It also has a scale which is movable. This one here is called vernier scale or movable scale. Vernier, the name vernier comes from the one who invented it. The one who invented it is called vernier. So it's this scale here, which can be slidden along the main scale, is called the vernier scale. So it can move this way, you can slide it this way. The vernier scale has 10 divisions. It has 10 divisions. If you count these, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each of these divisions is 0.9 millimeter. The distance from 0 to the end is 9 millimeters. This distance is 9, but there are 10 divisions. So each of the divisions on the vernier scale is 9 divided by 10 millimeters. So the scale on the vernier caliper gives readings up to 0.1 millimeter, or it gives readings of 0.1 millimeter or 0.01 centimeters. This is the smallest division, the smallest reading that a vernier caliper can give. It is called the least count. So the least count, the smallest value that the vernier caliper can give is 0.1 millimeters or 0.01 centimeters. Remember that 10 millimeters is to 1 centimeter. That means 0.1 millimeter is the same as 0.01 centimeters. Welcome, learners. So that's the structure of a vernier caliper. It has two types of jaws. The outer jaws, which are meant to help you in measuring the external diameter of a cylindrical or spherical object, and the inside jaws used for measuring the internal diameter of an object, such as a cylinder, for example, or test tube. So how do we use the vernier calipers to measure length? We shall refer to this diagram as we describe the use of the vernier calipers. It's the same diagram that I gave earlier on. Pay the best attention so that you don't miss any part of the description of how a vernier caliper works as a measuring instrument. So the object whose length is required is placed between the jaws. So you take the object and place it between the two jaws, making sure that it's tightly gripped between the two jaws. So this can be a spherical object like a ball bearing, or it can be a test tube whose diameter you'd like to measure. So you close the jaws onto the object to be measured, making sure that it's touching. The jaws are touching both ends of the object. You want to determine this distance. All right. So next you take a reading. You read the main scale. The main scale is this part from 0 to where the vernier scale starts, or the vernier part starts, this one. So let's say this is 1.4. From 0 to where the vernier scale begins, this is 1.4. So, having taken a reading from the main scale, you identify the mark on the vernier scale here, which coincides exactly with the mark on the main scale. Alright, so you look at a division on the main scale, rather on the vernier scale, these divisions, and identify the division which is coinciding. The mark which is to coincide means to face side by side, to be aligned with each other. Alright, so you identify the mark on the vernier scale over here, which is aligning with another mark on the main scale. So if you look at this closely, you find it is the third division. Just count 1, 2, 3. This is coinciding with a division on the main scale there. So you take that 3, having counted the number of divisions from 0 to where the coincidence is happening. So you take that 3 multiplied by 0.01. 0.01 is the smallest division, the smallest value you can get from a Vernier scale, which is called the least count. So 3 multiplied by 0.01 is going to give you 0.03 centimeters, which is the same as 0.3 millimeters. So in order to find the reading, you simply add the main scale reading to the Vernier scale reading, which in this case is 0.03. So the reading therefore is going to be 1.4 centimeters plus 0.03 centimeters, which is 1.43 centimeters. In case you missed this part, don't hesitate to send me a text message. I'll be glad to rectify what I have not made right in the first place. Welcome, learners. So, in order to find the reading, you shall use the equation, the formula. Reading on the Vernier Caliper is equal to the main scale reading, plus the Vernier scale reading multiplied by the least count. So the main scale reading is 1.4 centimeters taken from here. The Vernier scale reading is 3, just count from 0 to where the coincidence happens. That's 3 multiplied by 0.01 centimeters. So simplifying and adding will give us a reading of 1.43 centimeters. Let's look at an example. What is the reading on each Vernier caliper below? So in order to find the reading on a Vernier caliper, you look at the reading on the main scale to the left-hand side of the zero of the Vernier scale. So the zero of the Vernier scale is here. To the left-hand side of that, to the immediate left, you have 10 centimeters. So you write down the reading as 10 centimeters. That's the reading on the main scale reading. The main scale reading is 10 centimeters. Then you go to the Vernier scale and find a point where a mark on the Vernier scale is aligned with a mark on the main scale. This is called the Vernier scale reading, and then you multiply that by the least count. So the least count for a Vernier caliper is 0.01. So multiplying 2, this is 2, 0, 1, 2. 2 multiplied by 0.01. Whatever you get, you add it to the 10 centimeters. So the reading on this Vernier caliper is 10.02 centimeters. You do the same for this one. You identify the reading. The main scale reading is the reading to the left-hand side of the zero mark. So if this is 7, then this is 6, that means this one is 5. So the main scale reading is 5.0 centimeters. The Vernier scale reading is found where A mark on the vernier scale aligns exactly with a mark on the main scale. So that's 2. And multiply the 2 by 0.01 and add. The reading is going to be 5.02 centimeters. Welcome, learners. Alright, I would like you to work on the following. State the reading on each of the vernier calipers below. We are given 2 vernier calipers. You are to find the reading here and the reading over there. So the main scale is the one on top, the vernier scale is down here. So first of all, identify the reading on the main scale to the left of the 0 mark on the vernier caliper, vernier scale. So that's 18. 18.1. This is 18.1. So the reading to the left of this 0 is 18.1. And the coincidence is happening at 2. So use those details to find the reading. For this one here, the reading to the left of 0 is 0. And then you identify the coincidence. The coincidence is happening here. So use those details to find the reading on the vernier caliper there. Welcome to the micrometer screw gauge. Micrometer screw gauge is another way or instrument used to measure very small lengths. A micrometer screw gauge is used to measure accurately the dimensions of all small objects, such as thickness of a wire and paper. It can even help you to measure the thickness of your hair strand. So the structure of a micrometer screw gauge is this one shown here. It has a U-frame. This frame here is U-shaped. The use of the U-frame is to hold the anvil, this part called anvil, and the spindle. So the object whose dimensions are to be measured is placed between the anvil and the spindle on this gap here. It also has a sleeve. Sleeve is this scale here, which has a linear main scales, which is called sleeve scale. This one, marked in millimeters or half millimeters. So these values on top are millimeters from 0 to 5. That means this is 5 millimeters. And below here you have half millimeters. As it is shown here, this is 5.5. This is 5.5. So you have 0, 1, 2, 3, 4, 5, 0.5, 1.5, 2.5, 3.5, 4.5, then 5.5. It also has a thimble. Thimble is this part here, which has a circular scale from 0 to, it can be from 0 to 50, or it can go from 0 to 100 divisions. It is also called head scale or thimble scale. Welcome, learners. So when the thimble is rotated, when you rotate this, the spindle, which is this part here, can move either forward this way or backwards this way. At the very end there, we have a part which is called the ratchet. Ratchet The use of the ratchet is to prevent the operator, the student, or using this from exerting excess pressure on the object to be measured. So it prevents applying too much pressure when you are rotating this bit. So when you are rotating the thimble, the anvil and the spindle move closer and grip the object whose dimensions you are trying to measure. Welcome, learners. So that's the structure of a micrometer screw gauge. How do you measure small lengths using a micrometer screw gauge? So in order to make a measurement using the micrometer screw gauge, you rotate the thimble. So this can be rotated clockwise. So you rotate the thimble until the wire is firmly held between the anvil and the spindle. So you place the wire whose diameter is to be measured here. So you rotate, the spindle and the anvil move closer together and they grip the wire firmly. Once the wire is gripped firmly between the spindle and the anvil, then you take the reading. First look at the main scale. So you look at this scale here, which has a linear scale reading on it from 0. So take the main scale reading, and then if you look at the main scale reading, it has these long lines. Usually the ones below here are shorter than the ones on top. So the long lines are every millimeter. So this is 1 millimeter, 2, 3, 4, 5. While the ones down here are halves. So as it is here, the reading here on this micrometer screw gauge is 5.5. This is 5.5. Remember, these are halves. The ones below here are halves, while the ones on top are millimeters. So these are halves of millimeters. So this is 1, 1.5, 2, 1, 2.5, 3, 3.5, 4, 1.5, 1.5, 5, then 5.5. So this is 5.5. Next, you look at the scale on the thimble. So this line, the central line, must align to another line on the thimble. This one here is 10. So you take the reading on the thimble scale, multiply it by the least count. The least count for a micrometer screw gauge is 0.01. So you multiply 10 by 0.01 to get the second decimal. For example, on this diagram here, the sleeve reads 5.5. So this is 5.5 millimeters or 0.55 centimeters. In order to change millimeters to centimeters, just divide by 10. But it's common to leave it in millimeters. So where is the 5.55 coming from? It's coming from here. Sorry, 5.5. So this is 5, then 0.5. Over here it's 4.5. This one, this is 3.5 and so on. So this is 5.5 millimeters, while the thimble reads 10, where this central line meets this line here. Take that 10 multiplied by 0.01, it will give you 0.10 millimeters. So the reading therefore on this instrument is going to be 5.5 millimeters plus 0.10 millimeters. So adding these together will give you 5.6 millimeters. Welcome learners. My name is Mr. Pochilola, your teacher on this platform. It is pleasing to have you in my class. So that's how we use a micrometer screw gauge. In case you have missed a point, don't hesitate to leave a comment in the comment section below. It is going to please me to come back and rectify where I did not clarify in the first place. So in short, what we are saying is when you are determining the reading from a micrometer screw gauge, you take the sleeve reading, add the thimble reading, which is the reading on this scale, obtained where the central line and the division or one of the values there coincide. It's right here. Then multiplied by the least count, which is 0.01 millimeters. So multiply this and add, you get 5.6. Let's appreciate some examples. Suppose you are asked to find the readings of each of the following micrometer screw gauges. Alright, so take note, the main scale, the sleeve scale has a reading of 2.5. This is 2.5 millimeters, and the central line is coinciding with a mark, a division on the thimble scale at 26. So you take this 26 multiplied by 0.01, whatever you find, add it to 2.5. So that will give you the reading on it. I think there was miscalculation here. So this is supposed to be alright, so this is supposed to be 2.5. So in order to find the reading, you take the reading from the sleeve scale, which is 2.5, then you add it 26 times 0.01. So when you add, simplify and add, you should be able to get 2.76. So this is supposed to be 2.76 millimeters. Let's look at this one. The sleeve reading here is 10.5. So we have 10.5. And this is coinciding with 16. So the reading therefore is going to be 10.5 plus 16 times 0.01. Always remember to multiply the reading, the thimble scale reading, by the least count. So multiplying and adding will give us 10.66 millimeters. Alright, so before I go, this is for you. Step the reading on each micrometer screw gauges. Remember to share your responses with me. I would appreciate if you are watching on our YouTube channel. Simply write the answers, making sure you say A is equal to